Yeah, when I started working in Weights and Biases a year ago, I thought like we should have an MLOps meetup in Warsaw. I was thinking of starting one, but then I procrastinated well over a year, and now I'm happy because I would never be able to organize so professionally as our host. So thanks a lot, Agnieszka and Tomek, for organizing it. Really appreciate it. Cool. Quick introduction. So I will talk about MLOps, and I have some MLOps background. So right now I'm working in Weights and Biases, which is an MLOps company as a machine learning engineer. Before that, I spent quite a bit of time, 16 years, working at Procter & Gamble, and I had several jobs there that involved ops or MLOps. I started actually in supply chain operations. I was managing supply chain systems like SAP, making sure they run reliably, they deliver business value. Then I moved on and I worked on operational excellence in business process services, managing outsourcing services and how they deliver like with quality on SLAs and so on. And last couple of years, I worked in intelligent automation COE, which was about identifying business transformation ideas where we could apply advanced technologies, like including machine learning and AI, to automate business processes and deliver value ultimately. And there I also collaborated with ML platform team to establish a platform to host our ML-based solutions. So when I started in Weights and Biases, I thought I know something about MLOps, but I wanted to educate myself. And then I bought a couple of books. I think I had a stack of like 10 different books on MLOps. And I started reading them, and all of them started, like actually most of them started with this stuff. Like they usually motivated MLOps in DevOps. Like, hey, we have DevOps in software engineering, so we should have something similar in ML. So let's slap ML on top of DevOps, and that's gonna become MLOps. Most of it was focused on automation, and very often it was motivated by this fact that, like 90% of machine learning projects are failing, or more than that. And if only everything was automated, there were no Jupyter notebooks, then all of these projects would be successful. And I thought like this, and something is not working for me because Docker desktop is starting. So speaking MLOps, yeah, you need Docker desktop if you want to run Weights and Biases launch. So a small product advertisement, you can check it out. Yeah, so I read all of these books and I thought like this doesn't make sense to me. This is not how I understand MLOps. And the reason I think this is wrong is first, like there are many different reasons why ML projects fail. Like in my experience, it's not all about automation. In fact, like I believe automating too early might be actually not such a good idea. There isn't like a one size fit all. Like you can sometimes see these architectures where you have like a set of solutions. Like typically there is like a feature store somewhere in the middle. There is some orchestration system, and they say like, hey, this is like an MLOps solution, like an architecture, adopt it, and like all of your problems will be solved. I thought, no, this like doesn't seem like the right approach. So there are many different problems that need to be addressed. There isn't one size fits all. And for that reason, like we actually partnered up with my co-authors for this white paper, Hamel Hussain and Brian Bischoff, and we thought, okay, let's write our version of the MLOps story. Like, what does it take to implement MLOps successfully? And you can actually download this white paper. I think it's the link is in the meetup invite. There's also, you can access it at wandb.me/MLOps. So yeah, I recommend you check out this white paper, and I will talk about some of the points from this white paper in this presentation. All right, so how do we define MLOps? Like in my mind, machine learning operations, it's like there is an operations component there. So it means like you actually run machine learning models in production to deliver some business value. And you, in order to run these ML models, you also need to run machine learning projects. You need to discover ideas where you apply MLOps. So it's like this holistic approach. And in order to deliver business value with machine learning, you need a combination of different things. You need people, you need ML practitioners, people that will train models, people that will identify ideas to be automated with ML, people that will run your infrastructure, people that will maintain the ML systems. So there is a set of roles that you need to hire for, and you need to put like somehow structure in your organization. There's a bunch of processes that need to be established. And again, these processes go all the way from identifying projects to apply machine learning through experimentation, modeling, deployment, production, and maintenance. And finally, there are platforms and tools. And most of the books, most of the articles I read are focused on technology. In this white paper, we actually leave technology to the very end. Technology should be a solution to your problems, and you should not like treat technology as something that you just adopt and then it will solve all of those problems. All right, but speaking of platform and technology, in this presentation, I will mention some of the weights and biases solutions for some of the problems that you might be facing. So I thought it might be good to introduce weights and biases. So I need to drink. So if does anyone like who knows weights and biases in this group? Please raise your hand. Definitely our friends from Neptune know about weights and biases. We know about them. All right. So weights and biases is MLOps platform, but actually it's a set of tools for machine learning practitioners. And if you look at this slide, there's a bunch of these tools. You can adopt them as a like kind of in combination. When you buy weights and biases, you get access to all of these tools. But you may also like pick some of these tools that are relevant for you. For example, very recently we have a lot of people that are not training models but prompting large language models through APIs. We also have a tool for them that is called Prompts. It supports this prompt engineering workflow. You can use this tool without the rest of the tools potentially. And then all of these tools are integrated together, and they also are integrated with different machine learning frameworks. Like you can use them in combination with PyTorch or TensorFlow. You can use them on different infra, like with different clouds, with different orchestration tools. So it can be well integrated into whatever set of tools, infrastructure, compute you have in your organization. The reason I joined weights and biases, like I was like after 16 years in P&G, I was wondering, should I go to this company or not? And like this is the thing that convinced me. The list of customers, starting with companies like OpenAI, Genentech, Pfizer, lots of very successful companies doing cool stuff with machine learning. They use weights and biases. They get a lot of value from that. And I thought, okay, this product must be good. So I'm gonna start here. Yeah, so back to holistic approach to MLOps. So together with Hamel and Brian, when we started writing this paper, we thought, okay, let's brainstorm. Let's list all of the problems that we faced in our history, applying machine learning in businesses, in companies. And we came up with this like huge list of problems that you cannot definitely read in this slide. You can read it in the white paper. We put them in a checklist. And we thought it makes sense, you know, when you plan your MLOps architecture, when you plan like how to implement MLOps in your company, it might make sense to go through this checklist, identify the problems or the opportunities that you're facing, and then pick the right solutions for those problems. So hopefully some of this will resonate, and I will go through some of this. I will go through some of these points in the presentation, and I will also mention talk about some of the stories and problems I faced in my experience. Starting with people. So my story here is back in my previous company, working on a project where we wanted to automate master data with machine learning. I don't know, like there's a bunch of folks here from Allegro. You probably spend a lot of time on master data. Other big companies, like they also spend a lot of time on master data, especially if you have like hundreds of thousands or millions of SKUs. It's something that would be very good to automate to some extent, and machine learning seems like the right tool. There is a lot of business value, but then in my history, especially like in the first projects that started like looking at automating master data with ML, we had this team of experienced data scientists come, get some data set, work on it for a couple of months, come up with a model that they thought is like super accurate, and then present this model to the business, and the business would just laugh at them, like say like this is totally unusable. and it didn't work out, and they say like, hey, like business is stupid, they don't trust machine learning, they think they can do it better, machine learning can do it better, and like ultimately like that project was not successful. So a couple of years later, we took another approach at this opportunity, but we went a little bit differently about it. And we decided we're going to work very closely with the subject matter experts that actually maintain master data, and we will make them part of the process, part of the project to develop this solution. Starting with identifying of the data, labeling data, trying to build very quick prototype and see like how the model is performing. And then they will say like, hey, the model is making these errors. And we would like work together with them and say, okay, so how do you know these are errors? Like what features do you use? Like what signals do you use to decide these are errors? And like this way we would come up with a bunch of features. And then we would iterate, we would run the model, we would present them with the predictions, like they would again like go through this cycle. And with a couple of these cycles, like we actually got to a model that worked quite well. And the really important thing is like the business really started to trust the model because they were part of the team that actually developed it. They treated it as their own creation. And this is where I feel like this close collaboration between machine learning engineers, data scientists, and business is very helpful. And part of it is enforced through organization structure. How do you run projects? Like how do you collaborate with the business? But it can also be supported by tools. Specifically, weights and biases can be treated as a system of record where you put all of your machine learning experiments. And it has this great feature, which is reports, where you can like pull data from your experiments. You can publish this like as an interactive blog post, share that with business and use that for communication. They can comment there. In like when I work on that project, we didn't have this tool. So what I did some experiments in Jupyter Notebook, and then my business partners couldn't use Jupyter. So I would then export this to HTML, attach it to email, like send over email. Not very efficient. I recommend to use weights and biases reports instead. Okay, so the second set of processes, this goes a little bit into like how do you manage, how do you identify machine learning projects, and how do you run machine learning projects in your company. I like going back to the statistic, like how many machine learning projects fail. Like it says like 90% of machine learning projects fail. Definitely that's also my experience in like when I worked on applying machine learning to solve business problems. But actually, in my experience, this was actually something very good that 90% of the projects fail. And the way, at least in my group, in the Intelligent Automation COE, we worked is like we identified like a big list of potential ideas, potential applications of ML. We would develop like quick proofs of concepts. A lot of these proof of concepts would fail, but they would fail very quickly without big investment. And then some of this, like we would realize like, hey, there's a big business value there. The proof of concept worked. We proved the value, and then we would make them into big projects that would ultimately like get all the way to production. So I think it's okay that a lot of projects fail as long as you can quickly iterate and ultimately like also be successful in those projects where you actually find value. So speed of iteration is important. Again, the features of weights and biases, tracking all of the experiments, using reports for collaboration, using tables for visualizing data can be very helpful to increase the speed of iteration. And I think like thinking about MLOps as kind of like in this automation paradigm, I think automating too early can actually be hurtful. Like if you try to go like from the very beginning in this automated approach, you will like first like your iteration speed may be slower, and the cost of some of these projects that potentially like might not even have enough business value would be higher. So definitely automate, but not too early. That's my experience. Governance. Another story. I work with a team in a company that developed a machine learning solution, and they didn't have machine learning engineers or data scientists in-house. So they worked with an external company, an external partner that offered like machine learning, solution design, and implementation. And I was like an internal consultant, like I didn't work on that project, but I had some machine learning expertise. And at some point they came and say, like, we're spending so much money. I think it was in, a couple $100,000 spent on that project. Like, we're not sure if we're getting the right business value. And they asked for help for assessing like how this goes. And I asked them, okay, so tell me about the business problem you're solving. And it was a pretty straightforward NLP problem. So I asked them, okay, can you share me the code, like what was developed in this project? And they said they don't have access to the code. And then I asked them, okay, so how do you manage this project? And they say, well, we're getting like a weekly meeting with the vendor, and they're showing us like a presentation with the results. And that is an approach which I would definitely not recommend. And like here specifically, having a tool like a machine learning system of record where you like that is integrated with like code repository like GitHub, where you store like all of the experiments, the results, where you can also store the models. Because once you like in this situation, like working with that vendor, imagine like you take like even like let's assume this project is successful. You get a model. I don't know how you share that model, maybe over like FTP, maybe over email, like whatever. You get model weights, you implement it. But then if somebody asks about that model, or if it needs to be maintained, like how do you know, like what data set was it trained on? Like what was the training protocol? What were the hyperparameters? Like how do you go back and understand all of this lineage and history? Like it's impossible unless you have a system of record, like with a model registry, tracking the lineage, what happened during the training, what data set was used, which version of a data set, what was the code state at the point of training that model. Having all of those information can be super helpful, and especially like with regulatory requirements, with audit requirements, it's something I would recommend to establish. And it also helps with productivity. Imagine people going on vacation, leaves, potentially leaving company, making handovers. Having all of the history of your model training can make your team more productive ultimately. And now we get to automation. Once you went all the way, through identifying project, figuring out where the value is. The value is there. You have a working model. You need, like, you've deployed this model. You often need to regularly retrain that model, especially if you want to prevent like the situation where the data is drifting. Maybe the model might not be accurate. It's good to retrain that model on a regular basis. Potentially, you may need to scale and go from one model to a couple or a couple hundred models. For example, like you might have a model per customer, and then you might get into a situation where there's like exponentially more models in production at some point. At this point, having tools for orchestrating the workflows, orchestrating the data pipelines, automating, like having automated code checks with CI/CD, then it becomes very important. So again, like this is like what most of the MLOps books are teaching, and I think it's important, but it needs to come at the right stage and solve the right problems. And finally, we get to ML platforms. There are many different approaches you can take. Seen some companies that try to build their own MLOps platform and build all of the tooling internally. That is often very difficult. I think there might be some companies that are successful at that, but it's often at a very high cost. And like first you need to fund like the internal engineers to develop those tools. Beyond that, you need to fund engineers to maintain those tools. And it takes also time to develop new features. And for that reason, sometimes it might be better to buy some of the tools. The other thing is that I would take into account is user experience. I had a situation in my experience. I've heard from people that need to use tools that were mandated by a company that were a pretty bad user experience, and that hurts productivity, that makes you unhappy as a machine learning engineer or a developer. So getting the access to the right tools with the right user experience can be a good benefit for your organization. And one thing that I'm super proud about working at Weights and Biases is first, like it's very quick to start running it, and we get very good feedback from our users. The NPS, Net Promoter Score, is like I think better than Apple. So if you haven't checked out the tools, definitely do. And my final slide, this is something that I spent a lot of time at work, is building courses that we offer for free for everyone that can be accessed on our platform, wandb.courses. Specifically, we have a set of courses around MLOps, starting with our model development course, which covers most of the Weights and Biases products. We recently launched 2 new courses, one on CI/CD with Hamel Hussain. He's one of the experts. He used to work at GitHub on GitHub Actions. He's also an expert in MLOps, and great course. I recommend it. And we just this week launched another one with Shreya Shankar, who is another she's focused on she's a researcher specializing in managing data-driven, checking for data corruption, and she just developed a course on data validation for machine learning. And it's very short. It's available for free. Definitely, I recommend you check it out. And this is my last slide. So thank you very much, and would love to get any questions.
Yeah, hi. Thank you for the presentation, and maybe this is a stupid question, but I need to ask it. How it changes when you get the sensitive data in your operation? Does the sensitivity of the data somehow decides what the MLOps processes do you use?
Great question. Yeah, I definitely agree. Sensitivity of the data is one of the factors that you should take into account when building your MLOps architecture. And I think we also included this on that checklist. I would say, yeah, depending on the type of data that you handle, you might have different restrictions. I know some companies that cannot let their data go outside of their data center. And then you're limited to the tools that you can install on premises on your own data center. There are some companies that require SOC 2 certification. And as long as you get that certification, you can use a public cloud or SaaS provider. So depending on the type of needs that you have on the data, I think as you decide on your tooling, on your processes, that needs to be a check mark, like a requirement that you will need to verify. Specifically when talking about weights and biases, and again, weights and biases does not solve all of the MLOps needs. We offer some tools that solve some of the problems, but we have an option for local install on premises. So then all of the data is restricted to your infra. We also have the SOC 2 compliance, so you can depending on the needs that you have, at least our platform can usually meet those needs. But definitely something to consider.
You mostly talked about what happens during the development of machine learning models. What are your thoughts after deploying the model, monitoring the model in the production, looking at data driven, something like that?
Great question. I would say going back to the slide where we talked about this holistic approach, you have people, processes, and platform. And I think for what happens in production, definitely you need to also take this into account. Who is looking at the model once it goes live? This requires some organization design. And again, I don't feel there is one size fits all. In some companies, it might be the machine learning engineer that developed the model that continues watching it. In other companies, there might be a dedicated support team that is that will hand over the project in operations. So you need to think into who is monitoring that, who is maintaining the models. depending on how static or dynamic your data is, you might want to schedule like regular retraining. In this data validation course that Shreya did, like she actually recommends like if you have that option, like you should regularly train a model because it keeps it fresh. That's the simplest solution that solves a lot of these data-driven problems. Yeah, so that's another like dimension on kind of like the process, like how do you, like what type of problems you're facing in production. But on the other hand, like, you know, some of the other problems, maybe, you know, with NLP, maybe like you only need to retrain a model like once every 6 months. Like some of these models also might be like much more expensive to retrain. Yeah, so great question. Like I think like you need to look at people, processes, like what tools you need, and build a solution, like builds an MLOps approach that solves for those needs. But agree, this is a big component of the ultimate solution.
Hi. So if I understand, you provide the platform and then the company can develop the model themselves who buy the platform, or you also develop the model for them if they wish so? Great question. In our case, we provide tools for ML practitioners. We do not provide services. If you have machine learning, like we don't build models for customers, like that's not our business model. Like we provide tools that make developers more productive, machine learning practitioners more productive. Okay, so they can use the platform, develop the model themselves, and then. Yeah. Okay, and you actually mentioned auditing. I'm actually working on audit of models. So what, because the problem is with the black box here with machine learning and you know the data as you mentioned. So what tools would you have? What tips would you have for auditing machine learning model?
Great question. That's probably like a longer conversation, and depends a bit on. I think it depends on what type of requirements you're ultimately facing, right? So that's where I would start. If there are some regulatory requirements, like, you know, in Europe, there is AI Act coming, which I'm not an expert on, so I will not comment, but it probably has a list of things that you need to ensure while deploying models. And then that will probably like drive the work that needs to be done. If you don't potentially have this external regulation, but maybe you want to ensure fairness, then that's something that you would test for. And again, like this is like where we believe like it's very hard to build like a one size fits all tool, because different companies might have different dimensions of fairness. Like, you know, we're at Allegro. Like I imagine like when you deploy models, like you want to ensure that are fair, but like what are dimensions of fairness? Like what are the different groups that you would want to make sure, like, you know, I don't know, like that requires business knowledge. So there are tools that help with like interpretability of models. They are probably better developed for some of the traditional models, like decision trees and so on, probably less developed for like deep learning models like neural networks. But ultimately it comes down to like business expertise and domain knowledge in like what you're actually trying to audit for, and then working very closely and collaborating with people building the models that to achieve those objectives. So yeah, I guess my only tip would be, you know, structure your organization in a way that the auditing team that knows the requirements works very closely with the people building the models, and they work as one team rather than, you know, sitting on two sides of a fence.
Hey, thank you for the talk again. My question is more about processes, because I've seen MLOps being applied as a two-phase process. First, we have POC projects, and only then the automation happens, very often with a handover, completely shuffling the team, right? And you have mentioned that applying MLOps and automation too early might be hurtful. So where would you see the boundary? And I would ask specifically about the software support side from the MLOps point of view, like tools for data scientists who often do not write great code, right? Often when going from the POC, it's rewritten, optimized by different people. So tools which would ease this during the POC phase, which I see as part of MLOps, I think would be beneficial. What is your view on this?
Great question. I don't know if I have a solution for that. I think this is one of the hard problems that's where there is not like an easy solution. I think, again, going to this holistic approach, I think part of the solution is potentially educating the data scientists. So one of like a very successful projects in my previous work was having the MLOps team, the people that work on deploying model, do a very intensive training for the data scientists. And after that, like the data scientists like open their eyes and say like, wow, like we learned so much, and like it resulted in improved their work. And on the other side, like the MLOps team, like they also got a better like understanding of like the data scientist workflow. So I think maybe closer collaboration. Like I think potentially the solution is not on the software side, maybe more on the organizational side, because yeah, ultimately like the data scientists, like at some point they need to like it would be helpful if they write better code, but like they also face some constraints. Like ideally, like they should move very quickly, like iterate fast. Like some of these bugs will be scratched because like they will not deliver business value. So ideally, they should also not invest too much time up front. But then also like in many proof of concepts, that's something I found. Like there is like an element of a proof of concept where you prove like can you build a model, but in many projects like actually building a model is trivial. But the thing you need to prove is can you actually run this on a going basis, and maybe like you need to like have some version of a pipeline working, and then because that's where the POC might break. Like maybe you do not have the right data at the right time to make the right decision, and then the proof of concept is actually like building a pipeline, not training a model. Training a model is just one line of code in many cases, like sklearn.fit or whatever. Like that's like you don't prove anything. But like if you develop a very simple pipeline, then that might be actually like what you need to do in some cases.
You mentioned some tools on your platform for working with prompts and language models. Do you see some emerging needs for running large language models in production when it comes to monitoring or evaluation? Or where do you see the gaps between what's already there and what's needed? And do you see some major differences in terms of requirements for language models compared to the typical machine learning?
Great question. So what we see is first, like we see this becoming like a really important space. Like a lot of companies are actually adopting LLMs and using them in production, and then when I kind of like look at what the people building applications on top of LLMs are doing, is first they're doing a lot of experiments to make sure like they deliver on the business need. They then like once they go through this experimentation, they need to implement it. And well, first before implementing, they need to evaluate it. Like how do you compare those experiments? How do you know if this version of the prompt is better than the other version of the prompt? It's a challenging problem. So you have experimentation, you have evaluation, then you need to deploy this in production, and then obviously like you need to monitor this. And this workflow is very similar to the work like a regular machine learning project workflow. However, there are different things that you actually do in that experimentation process. Like first, like you're not tuning hyperparameters. Like maybe you're changing the prompt, maybe you're changing the LLM, maybe you're changing like the way you actually call that LLM. So you have different like levers that you touch, but essentially like the workflow is quite similar. And then that means that like you also need similar tools. Like you need some tools to log those experiments, because you've done maybe like a lot of work, and then at some point in the future you might want to go back and see kind of what worked, what didn't, so that you can continue working from there. So you need to log those experiments. Evaluation is probably the thing that I have like is in some extent like an unsolved problem, because the outputs are unstructured, very subjective.
So depends on the type of problem. Like if it's a structured problem, when you have like a label data set, maybe you can do it. People are using models like LLMs to evaluate LLMs, which has its own set of problems and challenges. So evaluation is probably an unsolved problem still. But then production monitoring is also like similar to traditional ML. Like you need to watch what's happening and react. Maybe the solution is different. Maybe it's not retraining. Maybe it's changing the prompt again. But the workflow is more or less similar. So the tools definitely need to be adopted because like you're kind of moving different levers in that process. But probably there are similar tool categories.
Hi. So there's that constant debate on build versus buy of MLOps platforms and components. And from my experience, companies usually try to build the platform from scratch until they figure out it's just too expensive. So I'm curious, like weights and biases obviously interacts a lot with different companies. And I'm curious from your experience, is there any particular MLOps component that companies decide to buy instead of building it from scratch because it's, for instance, too expensive?
Great question, and I'm obviously biased here because I represent a company that sells some of these tools. So my opinion is like you should buy weights and biases. But yeah, I think like maybe if I try to be a little bit objective and go back to my previous experience in my previous company before joining weights and biases, and definitely like there was a plan to build a platform there. That project moved very slowly. It turned out it was actually quite difficult. And at the end of the day, it was also like not building from scratch. Like it was assembling components, and you can like pick and choose different components. Maybe something is open source, some of them may be commercial. So at the end of the day, it's assembling. Like you need to decide like at which level of granularity you pick. Yeah, but unfortunately I'm biased, or fortunately I'm biased here. So my recommendation is buy weights and biases.